So hello everyone, I am Sayan Mukherjee. I'm a fourth year PhD student working in the Department of Earth, Atmospheric and Planetary Science. So I like to describe myself as a person or as a scientist who is interested in the way the science works, not just the application. So the application is very important, but the things that goes behind that application is also very important. So I want to develop my own methodology that can be actually applied in the real world field by engineers and other people who are actually doing this deployment and doing the data acquisition and doing the processing, but using that methodology that's developed by the scientists. I try to develop new methodologies to try to come up with new techniques that can be used for analyzing the data that's on hand. As I said, like converting noise to signal, analyzing it, and trying to see whether it's actually telling us something that's going on beneath the subsurface. It's basically because I'm a geoscientist in a sense because I look what is going on beneath the subsurface. That makes me a so that makes me a geoscientist. But because I work with the data and try to see how it can be handled more in an optimized manner, I'm also a data scientist. And I also do sometimes what our advisor calls a data mining, trying to see what the same piece of information that we have collected can be used for different purposes, not just limited to one purpose, so that it's exploited fully. So we are trying to exploit the data to its full extent. That's the end of the day. Many of our scientists are actually trying to see like how can we help the society. So thing is that one of our research is where we are interested in trying to see how these techniques we can use to see how the environment is changing the subsurface. Just take, for example, one of our experiment is actually in the Illinois, where we collected data, actually ambient noise data, in the middle of a cornfield. And what we are trying to see, whether by using this seismic wave data, we can see how the moisture content or the groundwater level changes in the subsurface. And the reason it could be very useful because if you can monitor that in a long-term sense, you can tell those farmers when actually to irrigate their land. So when you can actually see by using the seismic waves, you can actually see how the land is drying up. You may not get the actual value of like how much drying up it is, but actually you can see the trend and see now it is going down. The soil moisture content is going down. So you can use this data to tell them or to make a policy or something like that, that this is the times you need to irrigate, rather than just relying on traditional timings. Okay, this is the month we irrigate. Because otherwise, you have to rely on sensors, which are very costly, and you have to deploy it at multiple places. So this just single pieces of sensors or some like tens of sensors can actually tell or cover a longer area and give you a measurement which is like more wider in a sense rather than just point-wise measurement that could be done using a sensor.